All right, so if this is anyone's first time joining us, this is Paul Crout. He's with Helena, and he's been involved with the vineyard team for several years. He is currently serving as our board vice president and has been our treasurer for many years before this. So he's also been helping us with these Chapter 14 webinars for a few years now. He knows this chapter inside and out, and it's super helpful for us because we always have questions on it every year. It's a very involved chapter with a lot of calculations, a lot of conversions. So Paul, we're super grateful to have your help on this.
I am absolutely happy to be back again. I think this is year 4 that we've been holding this, and I think it's a really valuable training, especially for those first-time growers who are filling out their forms first go around. The great thing is nowadays we have a ton of resources available to growers to help them basically do these calculations. Back in the day, being a former grower vineyard manager myself with some SIP certified vineyards and filling this out, we didn't have these resources, and it was obviously a little bit of a bigger challenge. But over the years, the system has improved greatly. But still, this is ag math. And there's a lot of conversions and things like that that can be confusing. So really the point of this this workshop is really to go line by line through chapter 14 to give you, the grower, not just the answers or the information that you need to enter into the form, but also kind of the why, like where is this coming from, and why are we looking for this information as it relates to your farming practices. And so yeah, this form will, as you mentioned earlier, will pop up flags, and we are actually provide resources to help support during that process. I myself am on call and happy to be able to answer questions down the road. So as we finish this, my contact information will be there. You can reach out to Whitney, and then we can connect, because yeah, sometimes the numbers, you think you got the numbers and they just don't add up, and we can talk through it and get you there.
Yeah, that's always super helpful. We actually we did that last year. We had a member who was getting a lot of flags and had a lot of out of range data, so we just set up a quick call with you, Paul, and the member,
Yep.
and we went through it all and we figured it out. So we really appreciate that individualized help because it's needed sometimes.
Absolutely, absolutely. Well, I've spent 20 plus years doing fertility calculations as an agronomist on the Central Coast. So this I do this every day, so it makes it a little bit easier
Yeah.
to be able to talk about it. So yeah, why don't we get rolling with this?
Oh, actually, before we do, let me
Oh,
just say real quick. I know we weren't recording the first time and we hit everything we need to hit. Now we're recording, so I just need to remind everyone, Chapter 14 is due December 5th. And same as last year, we are partnering with Preservation Inc. to submit TNA reports to fulfill Ag Order 4.0 for growers in California Regional Water Quality Control Board Region 3. So that's the Central Coast. So since you're giving us all of your nitrogen and water data anyway through Chapter 14, we're just saving you that extra work in completing the TNA report yourself. So we're doing it for you and submitting it to the Water Board on your behalf through Preservation Inc. So if you are a Central Coast grower and you didn't have us do that for you last year and you would like us to do it this year, then go ahead and email me, whitney@vineyardteam.org, and we can get your AW, AGLs, APNs all in the database and ready to submit. So yeah, and then if you have any questions throughout the webinar, there should be a chat box or Q&A. Just go ahead and put them there and we'll get to them toward the end.
perfect. And yeah, Whitney, if anything does pop up, because I've got my screen, I'm just looking at my presentation. So if anything pops up, just interrupt me and I will stop and answer the question. So
Cool. Thank you, Paul.
all right. Are we ready? Here we go. So vineyard water and nitrogen use. This is section 14.2 and 14.3 in the SIP documents. And we'll be discussing, actually going through all of chapter 14, some of the initial information, and then we'll be going over the calculator that is available, which makes some of these calculations really easy. And then I can show some specific examples within the actual site itself. All right, so There's usually a ton of things that we need that you need ahead of time in order to fill out this information. So we've got section 14.2, which is your water use report. So what that is that's your applied irrigation water, your applied frost water, if you have frost control sprinklers or a frost control system. Rainfall, obviously something we need to calculate. And then our nitrogen use report, which can be a little bit more tricky. And this is where some of the calculations and things like that come into question. But we're gonna need to understand and tabulate all of your fertilizer inputs, nitrogen from compost. So if you apply compost during the season, and then nitrogen found in your water. And so here we go. So this is chapter 14. This is a screenshot of where you, kind of your first page when you're going to fill out chapter 14 on, in the SIP report. So actually, hold on, let me throw my laser pointer in there. Okay, so you can see my little laser pointer there. So this is where your ranch is going to be, and your ranch group, and then your specific ranches or blocks, however you might have that formulated. You will be clicking on the submit answers button there. Actually, you know what? I'm going to bring up, just because we're here, I'm going to bring up 14.1. Which is your general parameters piece. This is where you're entering basically your acreage and your yield. So those are two things that you need to have for those blocks. Now, if you have multiple blocks and or multiple varieties within a specific acreage, then you just add that all together and then divide by your well, you add that all together. It will calculate, it'll automatically calculate out your yield average per acre. So key things to enter in there. So we'll go back. So we are going to go to the water use report. So as you can see, we're going to need to enter our applied irrigation water. So this is the total amount of irrigation water that we have applied over the course of the season. Now, a couple of important things to remember is, and this is across the board when we're entering data into this form, is look at the units. And so the critical unit that we're dealing with is acre feet per acre. Now, oftentimes, and I'll show you some examples, oftentimes you'll get water use reports in total acre feet, total inches, total gallons. We need to convert that to acre feet per acre. And that's where we have a very nice workbook that will help us calculate that. And I'm going to show you some examples. You also need to have documentation. I will show some examples of what documentation is to quantify or to prove or to show that those numbers are valid. So here's an example of a irrigation record report. This is a personal one that I had built. It can be anything from a spreadsheet. Ideally, you want it in a digital format that adds up things. Something handwritten in a notebook, by your irrigator isn't always the best way to tabulate it. So a way to get it into into some kind of tabular form is really important. So if you look at this form, you can see these are block numbers, these are irrigation dates, and these are irrigation hours. So what you need is you need to be able to have your block or ranch level information, total number of irrigation hours, total irrigation hours per block. We need to understand how many gallons per vine you have. So those are the emitters per vine. Do you have one emitter? Do you have two emitters? Are they half-gallon emitters? Are they 1 gallon emitters? And then we will do an acre feet per acre calculation. So I'm going to show you here, there's a block, and this is the total calculation for this block. So you can see there's 5.5-hour irrigation times, there's 9-hour irrigation times, totaled up to 133 hours of irrigation, which calculates out to 70 gallons per vine. And then based on the number of acres that I had, it was a 0.38 acres per acre feet per acre. I will show you all of that information here on how to calculate that in this next piece. So let's talk about these water conversions and calculations, because as you can see, this picture, these are NetFM pressure compensating emitters, probably the most common emitter on the market. The challenge is, if you look at these three emitters, these are three different flows. There's a 1/2 gallon, there's a 1 gallon, and then there's a 2 gallon per hour emitter. So you can't really tell just by saying, oh yeah, I've got a NetFM emitter in how many gallons per hour. And they are all stamped. So there's a stamp on pretty much every emitter in the market. NetFM they're made in Israel, so they're going to be metric. So they're going to be listed in liters per hour. So for example, this 1/2 gallon per hour emitter is approximately 2 liters per hour. So it will have a 2 on it. This one has a 4 stamped on it for 4 liters per hour as a 1 gallon, and this has an 8. But very important things to know. Now, if you have inline emitters, which are emitters that are inserted in line, those are a little more tricky to understand. Sometimes the tubing itself is stamped with the with the flow, but sometimes, especially in older tubing, those stamps have kind of worn off or gone away. So you're going to need to find out, hopefully from your irrigation supplier or whatnot, what that flow is. All right, so what information do we need on irrigation applied? Couple questions here. Do you have a flow meter? If you have a flow meter, this makes these calculations really, really easy. So if you have a flow meter on your wellhead, you are able to very accurately tell from one date to another, if you keep those records, January 1 to December 31, how much flow you have had through that meter, and you can do some calculations. So if yes, then oftentimes meters will have two different forms of calculation. They'll show gallons. So for example, if your meter is giving you a number in gallons for that period of time that you've tracked, you take that flow in gallons, you divide that by the number of acres that meter covers. So hopefully, if you have one well that's covering, an entire, say, 40-acre vineyard, you do that calculation. If you have multiple wells, then you need to know which one of those meters serves how many acres. So you've got your flow in gallons, you've got your number of acres, so you divide that, and then you divide by 326,000, and that will get you the amount of acre feet per acre that we're looking for. So for example, your flow meter shows that you have utilized 500,000 gallons, and you have three, and that covers 3 acres, and you divide that by 326,000, that gets you to 0.51 acre feet per acre for that block. Now, if you do not have a flow meter, then we need some other information. We need your vine and row spacing. So are your vines spaced 2 feet or 3 feet apart? Are they faced 5 feet apart or 6 feet apart? And then are your rows 7-foot row spacing or 8-foot or 10-foot? We need that information. We need the number of emitters per vine. So the number of these guys per vine. Oftentimes it's 1, or even more often it's 2. And the piece, as I mentioned, you need to know the emitter flow in gallons per hour, which is stamped on the emitter. You need to know your total irrigation hours. So how many hours over the course of the season were you irrigating? And that's why having that spreadsheet or having some form of tabulation is really, really important. So here's the irrigation calculator. And there's a number of ways we can show this, and actually I'm going to bring up, this is a screenshot. I'm going to bring up the actual calculator itself here. Let's see if I can do that. Okay, so this is the spreadsheet that is found on the SIP form. So I can show, I'll pop that up here. So if you see here, this water and nitrogen use report workbook, if you click on this link, that will open this spreadsheet, which is right here. And so basically all you need to do is fill in the boxes and it will do the calculations for you. So as we mentioned in 14.1, we were entering, we enter our total acres. So let's just say I'm entering 10, I have a 10-acre block, and the total yield is, let's say, 50 tons. So we're calculating 5 tons per acre. Now we go to irrigation, and there's a number of different ways for us to calculate our irrigation flow in gallons to get acre feet per acre. So as I mentioned, if you know how many hours you've irrigated, so let's just say we've irrigated 400 hours, the flow rate per vine is 1 gallon per hour. The row spacing is, let's say we have 8-foot row spacing and our vine spacing is 5 feet. If we hit enter, it automatically will calculate how many acre feet per acre we have applied based on the parameters that we have entered. Now, if you have liters per hour, as I showed with those NetFM emitters, you can enter the same information. So let's just say we entered 400 hours, and we have 4 liters per hour, and our row spacing is 8 foot by 5 foot, and enter. So it's 0.1 acre feet per acre. Now, the other piece is if you have a total number of gallons that you so for example, if you have a flow meter and that flow meter has said, okay, hey, you've irrigated 500,000 gallons, that will give you your acre feet per acre based on the parameters that you entered here. So this is based on 10 acres. So that is where you would basically fill that information out and enter that into 14.2.1. So if I slide over here, you can see I've done a little bit of a different calculation here. It was 400 hours, 1 gallon, 10 by 6, so 0.89. Whoop. So we would enter in our water use report for example, in the example that I showed prior, 0.89 acre feet per acre. And then you will drag and upload whatever information you have to basically prove that that documentation is accurate. So it might be a copy of that spreadsheet. It might be a tracker, a water use report from from an irrigation company, from a weather station that tracks irrigation, anything like that. This is where you enter that, because that's where the auditor will look for that information. All right. So as you can see, another calculation is in inches per acre. So there's because sometimes you will get reports done in inches. So if you do have a calculation for inches per acre, so for example, 10.7 inches per acre was your report, you divide that by 12 inches, that gets you acre feet per acre. And there we go. All right, now frost water use. Now, if you have frost control, we have to account for that as well. So here's where we're going to enter the frost information. So frost water calculation. Question is, do you have frost protection sprinklers? If no, then you enter 0, and then you continue on to the next form. If yes, you need the same information as your irrigation, which is the total hours of frost control run, the flow rate of the frost control system, and then run your same calculations as the irrigation system. So we're gonna again need to convert acre feet per acre into as our entry. Here's an example of a of one of the warnings that pop up, that it falls out of historical responses. So this is one way for you to help calculate, or to you know, just to check and make sure your numbers are correct. So you can see the average response is 0.03 acre feet per acre. But if you do not have your frost control, you enter 0, that's fine. So, oh, here I can go back, and one example of frost control that I like to highlight is that frost control are typically, sprinklers are measured in gallons per minute. And so because they're sprinklers, they're either impact heads or they're micro sprinklers, but the flow rate is so much higher that you're going to be, you know, dealing with gallons per minute as opposed to gallons per hour here, which is drip emitter. So that's something very, very important to know the difference of. So your irrigation system is typically measured in gallons per hour. Your frost control system is going to be measured in gallons per minute. So a typical impact head, you know, rainbird style frost control system in the range of 55 gallons a minute typically. Let's say over the course of the season you ran that system, you had a couple of frost events, so you did it for 8 hours. It calculates your applied frost acre feet per acre there as 0.08. So if you did apply frost water, this is where you would enter that information. Here I will go back. You will enter that information in your frost water use. Okay, now we go to rainfall. And rainfall can be basically, rainfall is usually given in inches as well, as we all know. And here's an example. I showed that example in the irrigation one as well. So let's just say rainfall was 10.7 inches, and rainfall is given in inch. That rating that you get from the weather service or whoever, that's in inches per acre already. And so we know there's 12 inches per acre foot. So if we do that division, we get 0.89. Now, how do we do some conversions there? First off, where are you getting your rainfall number? And that will give you various numbers, and we want to make sure that we're converting to the proper values. So what are your sources? The best source is an on-site rain gauge or a weather station. So if you have a rain gauge or you have a weather station and you're tracking that, and you're monitoring that, be it even just a regular, you know, cup style or cylinder style rain gauge, if you're keeping track of that and keeping records, that's good. Or a lot of weather stations have cumulative rainfall calculators in them. So here's an example. This is from a weather station. This is actually an old school graph, but if you look at this graph over this time period between basically January 1 and, you know, the cutoff was the end of July, it accumulated approximately 17.5 inches of rain. So that's where that report would show. You can use a weather service with nearby stations. So CIMIS, or there are other privately held private weather networks that are out there. So Western Weather's database, you can usually find a weather station that gives weather data. Here's an example of a download from that. So it's pretty complicated here, but what we want to look at here is total precipitation in inches for between January 1 I'm going old school here. This is 2017. I pulled this one. I've had this record for a while. But this is at the Templeton Gap in Paso Robles weather station. So between January 1 and no, it looks like January 25th. This accumulation here. Oh, this is sorry. It goes. It's the whole year. Just didn't fit on this sheet, but the total accumulation is 21.6. So that'll give you your inches per acre there. There are other online sources. You can ask your neighbor, hey, how much rain did you get? You just need to be able to document it in some form or fashion. So we'll say that we got 1 point, well, it should be 17.6 or whatnot, or 1.76 acre feet per acre. So that was here's our calculation. So we used that previous Western weather one. So we had 21.17 inches per acre. We divide that by 12 inches. That gets us 1.76 acre feet per acre of rainfall. And there we are. So let's go. Let me bring up the total summary here, and I can show you that. So if we're doing 10 acres and we've got 50 tons, we can save and continue. So we can say, just with our calculation, let's just say we got 1.34 acre feet per acre of water, because that was from our calculator here. And so if we look at our total calculator, if you've entered in your irrigation, here's your frost water, and then 14.2, this is the cumulative one. So let's just say we did 1.76 inches. So this tabulates all of our rainfall. I'm sorry, this is 21.17. This will calculate and tabulate all of your total water use, and we will enter that in as we go along. Here's our frost water. So our frost water was 0.08, and then our rainfall was 1.76. And we enter all that, and you will obviously add all of your information, your documentation into here. It's very important because documentation is required for the audit. We hit save and continue. Then we go to our nitrogen use. And so that takes us to nitrogen use, which is section 14.3. This is where things get a little more complicated, and that's calculating the amount of nitrogen. So let's talk about our nitrogen conversions and calculations, because fertilizer applied, and it doesn't matter if it is if you're organic, if you've applied organic fertilizer, if you've applied conventional, synthetic fertilizers, whatnot, all of this, if you've just applied compost, there is a nitrogen amount in there, and we need to calculate that out. So what do we need for this report? Well, we need the total pounds of N per acre. So pounds of nitrogen applied per acre. What are these sources? Your fertilizer. So NPK, we'll talk about that. Nitrogen, phosphorus, potassium. We're interested in this first number. Now, fertilizers can be dry. They can be liquids. And then you have compost, which is also a source of nitrogen. And then you have your irrigation water. So let's talk about fertilizer first. So nitrogen containing fertilizer. So dry calculations are generally easy, or easier. So for example, you've applied 20 pounds of ammonium sulfate, 2100 per acre. Now, all fertilizers have this analysis here. This is percent of the element by weight. So this is nitrogen, phosphorus, potassium, or NPK. So if you look at ammonium sulfate, you will see it's labeled 2100. That means there's 21% nitrogen by weight in this fertilizer. So what does that mean? Yep, 2100 contains 21% nitrogen per pound of fertilizer. So you have applied 20 pounds, you multiply that by 0.21, you get 4.2 pounds of N per acre if you had applied 20 pounds of 2100. Hopefully that makes sense. So here's in the calculator form. This is a screenshot of in the fertilizer calculator. So if I bring this piece over and we're looking at nitrogen, you can see here is solid fertilizers. You have multiple fertilizer applications and you have liquids. So for example, in our example, we had 20 pounds of nitrogen and there was 21% nitrogen in that. So it was 2100. That got you your 4.2 pounds. So that's how it gets that calculation, but it's a pretty simple formula right there. All right. Now, liquids can be much more tricky because liquids have different, what we call bulk densities. So liquids are measured in gallons, but those gallons may weigh a different amount. So for example, if you look here, a common nitrogen containing fertilizer, CAN 17, or calcium ammonium nitrate, 17%, that weighs 12.64 pounds per gallon of that 17%. But if you look at a blend, fertilizer blend with that's, for example, 888, that only weighs 10.85 pounds per gallon. So they're both a gallon, but this one obviously weighs a ton more. Now, this is an example of a cheat sheet that I've built, that I have the automatic calculator, so I know exactly how many pounds of nitrogen per gallon I can, I'm applying. But you have to convert the liquid to dry pounds, to weight, in order to make this calculation work. So let's look at these liquid calculations. Couple of key concepts: understanding bulk density. As I mentioned, different fertilizers weigh different amounts per gallon. So we need to convert gallons to pounds of nitrogen. So here's our example. You applied 10 gallons per acre of CAN 17. CAN 17 has a bulk density of 12.64 pounds per gallon. So if you take 12.64, multiply that by 10 gallons, you have applied 126.4 pounds of fertilizer per acre. And then we convert that by the percent of nitrogen per pound. So 0.17, because it's 17%. And that gets us 21.5 pounds of N per acre. So if I bring us over to this calculator again, go to the liquid fertilizer calculation. As I mentioned, we applied 10 gallons per acre. So here's 10, we'll enter 10. The percent nitrogen is 17 because it was 1700, and it was 12.64 pounds per gallon. So that got us to, automatically calculates 21.48 pounds, or 21.5 pounds of N per acre. Now, you need to do this calculation for every fertilizer application you make. So if you had 3 fertilizer applications that contain nitrogen over the course of the season, say you did a bud break application, you did a pre-bloom application, and then you did a post-harvest application of fertilizer, you need to account for all of those. And so where do you find all this information? Oftentimes in the industry, we use blends, maybe not just straight product. So you can get that information from your retailer or your fertilizer supplier. They can give you the analysis as well as the bulk density for each of those. Or if you have a really cool viticulturist agronomist like myself, I write out a fertility program that has all of this information already calculated for you. So at the end of the season, all you have to do, it adds it up all for you, and it's documented. But there's a couple different ways to get that. So here's the calculator, as I mentioned. And so let's look at a couple of examples here. So here's our summary. You applied you applied some ammonium sulfate, say, at bud break, or, before a rain or whatnot. So you applied ammonium sulfate and then you applied those liquids. So you have to account for your dry plus your liquid. That gives you a total amount of 25.7 pounds of N per acre. And so here's the summary, and here's the total that the calculator gives you. It sums it up for you. And so you will enter that in the 14 in the appropriate form here in your in the workbook. So let me go over here. So here it is. So this is 14.3. This is your nitrogen use report. And as I mentioned, I forgot, what was it? 25.7. So we entered 25.7 pounds of N per acre. And then you drag your supporting documentation there. So your supporting documentation might be, again, a summary report of all your fertilizer applications with pounds of N applied divided by acres. It could be fertilizer receipts. It can be a whole host of different things, but that's the information that you'll need. All right, and we go to compost. Same concept, just a little bit more tricky when we calculate for compost. So compost can be really tricky because oftentimes compost can be delivered or measured in tons per acre, or it can be measured in cubic yards per acre. So oftentimes, depending on who your compost supplier is, they will give you, we'll say, yeah, we applied 5 yards of compost per acre, or we applied 5 tons of compost per acre. Those are two completely different numbers, and so we need to be able to calculate those. So again, there's a very handy calculator to help do these calculations. So a couple things that you need is the amount of available nitrogen in your compost. You will get that information from your compost supplier. There will be an analysis of the compost, and it will give you a nitrogen content number, and it might be 1.7. Well, for the example that we're going to be using, it might be 1.7%. It might be 2%. It's going to be fairly low, but depending on what the compost source is, it will have different nitrogen amounts. If it's a dairy manure based compost, it's going to have higher nitrogen than green waste compost, just so you know. As I mentioned, nitrogen can vary depending on the source. As I said, green waste versus dairy, that percent N is on the analysis sheet that's going to be supplied by your compost supplier. And if you don't get it, ask for it, because it's really important to have that information. So we will estimate our compost using this example, which is 1.7% nitrogen compost. So here's the compost calculator. I know this is really complicated, but I think it's pretty simple once we were able to enter the information in the calculator. So you got your nitrogen compost analysis, or your compost analysis lab analysis, and it indicates 1.7% nitrogen, and then they'll also give you a weight to volume. So in this case, the compost weighs 900 pounds per cubic yard. So that allows us to understand that there's 15.3 pounds of N per cubic yard and 34 pounds of nitrogen per ton. And so we can take that information, and now here's the tricky thing with compost, because it's an organic form of nitrogen. Not all of that nitrogen is generally available in year one. Is immediately available. It breaks down over time. So there is an industry standard for estimating how much of that nitrogen is released per year, and that estimate, basically based on UC analysis, is 20%. So we use what I call a 20% multiplier when we are estimating the amount of N released in year one. So for example, in this case, we're doing a 20% release based on this 5-ton per acre applied product. So there was 6.8 pounds of N released in year one, and we had 5 tons applied, and so that's 34 pounds of N per acre applied total out of that 5 ton. And that pounds per acre you will enter that in the form. So here's going to be, I'm going to show an example of running the calculator here. Apologies for that. So here's compost right here. Oh, and it's already filled out. So we said, based on our lab report, it was 1.7% nitrogen. Our compost weighed 900 pounds. And let's just say, based on, again, university information, it's a 20% nitrogen release in that year one. And we applied, as I mentioned, 5 tons of compost per acre. And so that gives us 34 pounds of nitrogen that we have applied that will be released to that to the vineyard in year one. So we will enter that into 14.3.2, which is, let me go back, which is, sorry, I'm swapping between multiple screens here, which is right here. So as I mentioned, we're entering 34 pounds of N per acre. Oh, look at that. Don't know why that happened. Sorry. And it looks like it fell out of outside of historical responses, because again, we might have applied, let's just say that was 5 tons is, I don't know, 8 cubic yards, which is maybe more than some people might apply. But that's why we wants us to go back and just double check that. And so then you'll drag your documentation here, and that would be like the copy of the lab report for the compost, as well as load tickets or delivery tickets that highlight how many tons or cubic yards of compost you've applied per acre. And then finally, we're going to enter the amount of water supplied nitrogen. So remember, groundwater, and most of us are all on groundwater here, groundwater may or may not contain nitrate, nitrogen in the water. And so we need to account for that. So this is where, again, you will need a current water analysis from a lab. And that water analysis will indicate the amount of nitrogen, nitrate nitrogen, is in the water. Now, one thing that you need to be aware of is depending on the lab, there are 2 methods of reporting nitrogen or nitrate in lab reports. They are reported as NO3, which is nitrate, or NO3-N, so nitrate nitrogen. So they are going to be, it's going to show the multipliers and all of that are going to be completely different. So it's very, very important for you to note which element or which value of nitrogen the lab is reporting. And I believe I have an example here. So you need a water sample from your irrigation well. If you have multiple wells, you need multiple samples. And if you blend that water together in say a reservoir or into storage tanks, then you can take a single sample from the storage tank if that is if your wells feed into storage tanks and then you pump out of those storage tanks, you can take your water sample from those storage tanks because that will be an average, kind of an average of both wells. But be sure you get all of your water sources. Your report will give nitrogen in parts per million. That is a pretty common reporting. It'll either be parts per million or milliliters per liter, which is the same number. You'll also need your total irrigation, which you've already calculated. And so here's an example of a lab report. And so if we look here, we can see that it is reported in nitrate NO3-N, so that is nitrate nitrogen, in milligrams per liter, which is parts per million, same thing. And so the report gives us a number of 2.6 milligrams per liter or parts per million. So using a conversion factor of 2.74, which is on the submittal form, will allow you to, it'll calculate that for you. You can do the conversion, so 2.6 parts per million times 2.74 equals 7.1 pounds of N per acre feet. Now, this lab does the calculations for you too, which is kind of nice. So you can see right here, it does for ag use nitrogen calculations, it does the calculation for you. But this is how they get that, they get to that number, is using that multiplier. So if we go back, to the example, you can see that we're using its NO3-N, so the multiplier is 2.74, whereas if it was nitrate, the multiplier is 0.62. And that's just how it's measured as far as the molecular weight, but we don't need to worry about that. So as I mentioned, our water report showed 2.6 parts per million. In our example, that gives us 7.1 pounds of N per acre feet. And in our example form, at least on this, that we applied 0.89 acre feet of water. So that calculation, so 7.1 times 0.89 acre feet, gives us 6.3 pounds of N per acre. And we apply that right into the form. And we are good. We will be good to go. Now let me show you an example. We're entering this. Here is the actual form itself. So we've entered our compost. As we slide down, we enter our water, and we have entered our pounds of N per acre. So let's just say it was, like I said, it was 7.1. And then again, it pops out because usually it's higher nitrogen. And then it's going to ask you for enter nitrate nitrogen. So if that ppm, which was, I believe it was 2.6 ppm from my example, yes, we'll enter that. And then we hit save and continue. And guess what? That means we are just about at the end here. And here's the summary of all, this is the summary page. So actually here, I'll show you the actual summary page of what we entered. So we had our acreage, our irrigation water, calculates water use efficiency, total applied N in pounds of N per acre, our nitrogen efficiency. It looks like this calculator is running, it says I accidentally hit, I guess it was 558 acres instead of 10, but it supplies you that summary at the end of the report. And that's the end of the training. Now, so there's a ton of information that I went through. I went through it very, very quickly. You can go back to each, here was where my issue was, 10 acres. So you can go back and enter all this information. At each section is the link to the workbook. There are also tutorials on all of this as well. So there is additional online content, as well as there will be a recording of this this presentation available at the end of the day. But one thing I would highly encourage is to work through the workbook before you start entering information. So work through the workbook. You can see at the bottom tab, it's got each chapter and subchapter here that would, just like we worked through today. Enter all those calculations, and that will be able to allow you to then the pink piece is the pink box is where you enter into the web form itself. So this will allow you to get through all of it in one go, and then you just fill in that information in the web form, and don't forget your documentation. So with that, there's my contact information. Easiest way to reach me is via email. Always happy to answer questions, or you can also reach out directly to Whitney at the Vineyard team, and she can also point you in the direction of a ton of different resources. So with that, Whitney, back to you.
All right, thank you so much, Paul. Yeah, it's a big chapter. It's always kind of fun to revisit it though, because it is complicated, and it's cool to go through everyone's stuff now that we're doing this regulatory relief and kind of see what people are doing, and where the common errors come up, like the was it the inches per
Yeah,
versus the feet per?
inches per acre to calculate to acre feet. And I think one of the great things is that, with the Regional Water Quality Control Board and those requirements, all these calculations that we're doing meet and exceed the requirements for the Water Quality Control Board. So you only need to do the calculations once, and then the Vineyard team can carry that over. It's a great benefit at the end of the day, in my mind.
Yeah.
Yeah, it helps kind of make that process easier, because I'll tell you, the water board's calculator it's not even it is just, you have to do all the calculations. It doesn't give you any hints. It doesn't help calculate very, very well compared to this one. This one is way more user friendly to help do the math and walk you through that whole process.
Oh, okay. I haven't seen the water boards calculator, but I was thinking as you were going through our workbook, just how cool it is how we have the different units. Like if you do the liquid versus the solid
Yep. Fertilizer.
for
Yep.
fertilizer, it'll,
Yep.
you have it there.
Yep.
Cool. I had a question as you were doing the irrigation section for the
Yes.
row and vine spacing.
Yes.
What if somebody has a combination on their property?
That's a really good question. So if you have a combination of row and vine spacing, then what we need to do is we need to take those blocks individually, and do the calculations separately, and then add them together, and you get an average at the end of the day.
Okay.
So you need to do a little extra step. So maybe I'll do that in the next go around. So yeah, if you have a block, say a 10-acre block of 8x5 spacing, and then you have another 10-acre block of 10x6 spacing, you need to do those calculations separately, and then you add them together to get your total gallons applied per acre. So yeah, so there's a couple of other ways to do it, but yeah, you got to do them separate, and then you add them together at the end to get total gallonage.
Okay, yeah, that totally makes
So
sense.
and the cool thing is the calculator will do that. You just need to enter you need to just start with the acres, and then you'll do the calculator for that spacing, and then you got to go back, adjust the acres. So you note like block
Right.
1, and then you go back and do block 2, you add that together, and then you add them all together, and then divide it by the total number of acres, and that'll get you your number.
Yeah. Yeah, that's
So
something I didn't realize my first couple times through the workbook is what you put in on that first, the general parameters page. Like that really does inform all the other calculations. So if you do need to make an adjustment, like know that it's going to change everything.
yes, because that carries on to the amount of fertilizer applied per acre and everything else too. So that's kind of important, important to know.
Yeah.
So that's why sometimes like sometimes I believe you can and correct me if I'm wrong, when you're having you have your ranch, and then you have like your sub ranches, can you like go down to like the block level? I mean, it will add multiple, it might add multiple ways to calculate, but yeah, I would, yeah, if you have it all together, then you just got to add those blocks, add them up separately.
Yeah, yeah, you can't split up inside chapter 14, you can't split up a ranch into its separate blocks, but you
Right.
could, it might be a little more work, but you could name your ranch. Like if your ranch is El Camino Ranch and you want to split out the blocks, you could do El Camino Ranch 1, El Camino Ranch 2, and
Yep.
then calculate or split them out into separate ranch groups when you go to do chapter 14. Um, might be a little more work, but it can be done.
It is, yeah. So I mean, I think basically the key is at the end is you just got to add each, make sure if you have different spacings, or if you irrigated one block and you had, you irrigated one block 100 hours and then another block only got 48 hours,
Mhm.
you have to do those calculations separately and then again add them all together and then average that out in your total number of acres. So
Yeah.
that's again, because that's what we're looking for is the average amount per acre across the entire vineyard. So
Right.
that's important. Yep.
Yeah. And then a lot of people do have like they'll have contiguous kind of ranches. You can split those up into different ranch groups if you do treat them differently. So that's
Yep.
something that'll help you get a more accurate number, especially when it goes to the TNA reporting. Like it's always better, of course, if that is more accurate. So just do another ranch group. Like it doesn't take that long to go through the calculation workbook, so it could be worth it.
It could be definitely. It would definitely be for me. Yeah.
Yeah. Cool.
Perfect.
Okay, well, we don't have any questions come up, so I guess we'll just wrap it up then.
All right. Sounds good. Thanks, Whitney.
Yeah, thank you, Paul.